Okay, so now let's take a look at a few additional call routing topics. First of all, let's just take a brief look at where do calls originate from. Calls are possible, obviously, to come from phones. So users place calls inbound from the phones into CUCM to match patterns. Calls can also come in, probably also obvious, from gateways or trunks. So calls come from the PSTN by the form of gateways, or it could be said from a SIP trunk if the SIP trunk is being used as basically a SIP gateway to the PSTN, or from some sort of H323 ICT, which is intercluster trunk, or even SIP trunked partner. Calls can come in from voicemail ports and CTI ports as well. So calls could, let's say, come in from Unity Connection or even Unity Express from the voice message notification, or even just from a call transfer from an sort of an auto attendant menu structure, which is a system call handler, things we'll look at in Unity Connection, but those would come into CUCM from a voicemail port. They could also come from IP-IVR or UCCX, Unified Contact Center Express. And when calls came in from a UCCX IVR application, such as a call redirect step or something of that nature, they would come in through the CTI ports. And then also calls can be considered to come in through translation patterns. That is, the call first matched, the dial digits matched the translation pattern, and the call was transformed, and then it was sent back into CUCM, or really back to the digit analysis engine for further digit analysis. Taking a look at some of the digit addressing methods that we have available to us. IP phones, broken down into two protocols, skinny phones and SIP-based call signaling protocol phones. Skinny phones, by default, send digits by digit. So as a user goes off hook, the CUCM instructs it to play dial tone. The user dials a digit. Maybe they dial a 0 or a 9 or whatever our dial plan and route patterns are set to, or translation patterns are set to. And if all the unique digits match, that is, there is no ambiguity, and they all have the tick box for secondary dial tone, then CUCM will instruct the phone to play a secondary dial tone. And then each additional DTMF digit that's pressed is captured by CUCM one by one. And because of this dynamic back and forth relationship, this is what allows your display on the individual hardware or even software phones, potentially, to be able to, as long as they're skinny controlled, to be able to show the soft key for the back arrow or the double back arrow. Actually, really, it would look like the double less than. But basically, to go back one digit and erase that digit and put another one in its place. If CUCM was receiving all of the digits at once, then it would be, in other words, it was capturing all the digits that you were dialing from the phone keypad at once, and then sending them on to the CUCM all at once, which is what the next bullet is called, which is N block. But if it were doing that, then it would be fairly difficult to go back one digit, unless, of course, the phone firmware had that capability and that knowledge to be able to do that. But it would be very difficult to go back one digit and redo a given digit. But by default, calls sent from skinny phones are sent digit by digit. Now, there is a way to send them in block, and if we use the redial, or we dial something from corporate directory, if we dial something from a missed call or a received call, whether we just hit dial to return the call, or even whether we hit edit dial and then edit some of the digits and then hit dial, all of those are sent en bloc, which means all of the digits are sent immediately. Also, if we use speed dials or abbreviated dial, all of those are sent en bloc. So really, the only time when digit by digit is sent for a skinny phone is when the user goes off hook, either through speakerphone, handset, or headset, and dials manually from the keypad one digit at a time. Now, there's also another way to send in block from the keypad, and that is for the user not to go off hook, but rather just begin. So that is, they don't press new call soft key. They don't hit the handset. They don't hit the headset button or the speakerphone button, and they don't lift the handset. All they do is begin dialing on the keypad, and the unit itself, the phone itself, is collecting the digits, and then they either hit dial or lift the handset or press headset or press speakerphone, any of which will then also trigger all of the digits to be sent at once. So it's only when we go off hook first and then manually begin dialing digits that things are sent from a skinny phone digit by digit. Now, SIP phones, it actually depends on which model of phone you're using. There were some older models. You might have heard of them. They're fairly common, actually, in a number of places, just because so many people had deployed them, and they still work. And so, maybe they haven't upgraded or something like that. But Generation 2 type phones, and what are also lumped into the Type A phones, and I'll get into the distinction a little bit more. But as we move on in the video lectures, but the 7960 and 7940, those phones that could run SIP did not have the ability to do something called KPML. So they either waited for an interdigit timeout and sent everything en bloc, or they had to be configured with SIP dial rules, both of which we'll talk about. The newer phones, so Generation 3, Generation 4, even Generation 5 phones, all of which are labeled Type B phones, they have the ability, and actually the 7970 is a Generation 2 but falls into the Type B just because it had more flash memory, and so it could handle a newer firmware. And the newer firmware is really what defines the delineation between Type A, older, and Type B, newer phones. But these newer phones running the SIP firmware, and some don't have a choice, like the 9971, etc., they, by default, do KPML, or keypad markup language, or key press markup language, however you want to refer to it. But this is effectively a form of XML, a markup language, and the digits are being captured by the phone device and sent on to, in this case, their registered server or registrar server, being CUCM, sent one at a time. But this is actually an industry standard. So Skinny, of course, a proprietary protocol, SIP being an industry standard. KPML is also an RFC extension to SIP. It is a standard, and Cisco does not only honor that, but the phones use that by default. So they emulate something very similar to the Skinny protocol's form of digit by digit, using key press or keypad markup language, KPML. Now, all the same rules still apply in that if they're doing missed calls, received calls, hit the dial soft key, corporate directory, redial button, or soft key, all of those same things for the Skinny phone, those apply to SIP as well, that those will be sent en bloc. Now, the SIP phones do have something that we can configure in CUCM, and it's basically a mini dial plan, and then essentially tell the phones to pull down as part of their configuration. And these are called SIP dial rules. Again, these are industry standard, and so the way that we define these SIP dial rules, the actual characters that we use to define the dial rules, may seem and are a little bit different than what you're used to, or what you will be used to in terms of route patterns and translation patterns, and anywhere there's a pattern or DN field. Okay, so we'll take a look at those, but again, the reason they're different, because they follow the industry standard, and Cisco doesn't want to deviate from that. In order to be able to really be truly SIP, and not some proprietary version of SIP, they have to follow what the RFCs state. So we'll take a look at those. Some of the reasons you might want to do this, first of all, as I mentioned, the older 7960 or 7940 phones, if you have those in your organization, or a client is requesting them, or already has some, and they, for whatever reason, want those to be using the SIP protocol, then this is a very good thing to configure. Otherwise, you will have to wait for the interdigit timeout every time you make a call from one of those 7960, 7940 SIP-based phones. There's a few other, certainly any reason you can come up with. There's probably a few other reasons. Another good reason that we'll take a look at in the demo is something that we'll get into later in your studies, dealing with something called plus dialing. And when we have globalized numbers and plus dialing, which we won't unpack or get into right now, but when we do have those, you will have numbers that show up in your missed or received calls that show up beginning with a plus symbol. And in order to be able to return those calls without dealing with some sort of major interdigit timeout delay for all missed and received call returns, SIP dial rules, even for the newer phones that do KPML by default, because they do KPML by default, which is digit by digit, the way that the patterns are matched, especially if the patterns are marked urgent priority, all things that we'll get into as video lectures go on, but basically what you need to know for now is that those missed patterns can, because of KPML, introduce a lot of delay for SIP-based protocol phones, newer SIP-based KPML protocol phones that are trying to do return calls. So that will probably be the main example that we'll use, because we don't have 7960 phones here, in order to demonstrate SIP dial rules, their application, and why they might be needed. So also looking at gateways, MGCP, H323, and or SIP gateways, and I say SIP gateways, CUCM really doesn't have under the gateways section something called SIP. If you want to have an iOS router that is interfacing to the PSTN, which really does define a gateway, but is running the SIP signaling protocol back to CUCM. Of course, in CUCM, you need to define a SIP trunk, but we list it here under gateway just because, in fact, it is a gateway to the PSTN. But we have the ability to use NBlock, which is the default. We also have the ability to do something called overlap sending and receiving, and this is only for ISDN PRIs on all three of those protocols. And this is very similar to digit by digit, or in a sense KPML. So this is digits are transmitted or received one by one. Okay, so they're either transmitted to the PSTN one at a time, and the PSTN waits for the T304 timer, which is the interdigit timeout essentially for or really the overlap sending and receiving digit timer. And then they also we have the ability to receive calls from the PSTN. Also just over plain H323 or SIP trunks, so not necessarily going to an iOS gateway for Cube or for PSTN interfacing, but let's just say either to another cluster, to another CUCM cluster, to CME, to an ITSP. Again, for both H323 and SIP, the default is NBlock, but we can enable overlap sending and receiving. And the last bit we want to talk about, not necessarily always covered and not necessarily always thought about, and we'll certainly circle back to this one when we begin dealing a lot more with translation patterns as your studies go on. But translation patterns, after they match the dial digits, and then they translate their number, and then they send, obviously, everything, those dial digits back into CUCM for further digit analysis, they always send them NBlock. So when we're trying to match something specifically after it's been matched and transformed by a translation pattern, and I should say maybe if we're creating a pattern that we know or we intend to always be matched and only be matched after a translation pattern has done its transformation, a lot of times if it's a route pattern or possibly even another translation pattern, although that's less likely, we will make sure that we tick the box for urgent priority. Because and I'll just reinforce this, let's just use the example of a route pattern. If the route pattern that we are creating, we intend to not only Well, that we intend to match the result of a transformed called or calling number by use of a translation pattern. And we only ever expect, and certainly hopefully we design it properly so that it only ever does get matched after a translation pattern has done its transformation. Then we want to make sure that we tick the urgent priority checkbox so that there's no secondary interdigit timeout delay that's imposed. So looking at call routing types, we have three main types. The ones are intra-site, inter-site, and PSTN. Intra-site, obviously, calls are sent within CUCM to a DN. Okay, so calls are sent typically within a single site and within a single cluster to a registered directory number. Inter-site is broken down into two further categories, on-net and off-net. So inter-site, we're sending calls between sites, and calls use internal DNs to route between sites or between clusters. So this could be viewed depending on how the question is worded on an exam or how the client might be asking you about a particular call routing type. It might be that this is between two sites that are registered to the same cluster. So, between corporate headquarters calling over to branch 1, this could be viewed as on-net inter-site. Or some people choose to refer to that as intra-site, even though really that's intra-cluster to be more specific. Inter-site, but intra-cluster. Or they could just be referring to between clusters. And then dealing with off-net inter-site, so calls that ultimately use route patterns. They might first use translation patterns to be transformed in some way, and we'll talk about that a lot more as time goes on. But calls ultimately use route patterns, that is, the dial digits ultimately get to a route pattern to route the call to the PSTN, but between sites or possibly between clusters. So they're going off-net to the PSTN, off the network, but they are routed between sites or clusters. And then PSTN, these are calls that are, again, ultimately routed to route patterns, and they're ultimately being sent to the PSTN, but from within a site. So let's take a look at one other thing called time of day routing. Can be referred to as a form of call coverage, certainly. So call manager certainly has the ability, or communications manager, to route calls based on time of day. And the way that it does this is we create time periods, place those into time schedules so that we can create multiple periods within a given schedule, and then assign those time schedules to partitions. And so therefore partitions only remain active or appear to the calling search spaces that would normally contain them during a given particular configured time. So let's take a look. We see the RTP CUCM cluster at the top, and the dotted line there is just going to really infer the entire cluster configuration. And then we also see across the WAN is a San Jose site with phones. So we're going to use hunt groups actually as our mechanism for looking at an idea of time of day routing. So here you can see that we have a hunt pilot 1 with the DN or number of 8,000. It points to a hunt list, which points to a line group, which contains the phones, of course. And it's in, that is the hunt pilot, is in the RTP partition. Now the RTP partition has an RTP time schedule based on Eastern Standard Time, which is GMT -5, or if it's daylight savings, GMT -4. And then inside that RTP time schedule, there are 3 time periods. Time period 1 is Monday through Friday, 8 a.m. to 12 p.m. Time period 2 is 8 a.m. to 1700 hours on Sunday. And then time period 3 is July 4th, which is a bank holiday, no business, so everything's closed. So first off, on July 4th, on that particular date, the RTP partition does not show up in any calling search space. So therefore, as a result, Hunt Pilot 1 with the DN of 8000 does not show up in any calling search space. On July 4th, Hunt Pilot 1 cannot be reached at all. Also, Hunt Pilot 1 cannot be reached before 8 a.m. Eastern Standard Time on Sundays and after 1700 or 5 p.m. on Sundays, Eastern Standard again time. Okay, likewise for Monday through Friday. Only between 8 a.m. and noon does this actual partition and therefore DN appear in any of the calling search spaces that it is configured for. Now, this doesn't mean that if you were to go into the administration, the CUCM administration web user interface, and look in the calling search space, that you would not see this partition. You will still see it there. It's configured there. That doesn't mean that it's active or visible to whatever phones have that calling search space. Okay? So the partition is not active or quote-unquote visible, but I don't want to confuse when I'm using the term loosely of visibility. If the partition is visible to the calling search space that it's contained within, I don't want to confuse that with administratively. Administratively, you will still physically see it with your eyes inside that calling search space, but it's not active. Okay, now we also have the exact same DN, 8000, inside of another partition. Now we've already looked at and know that the only time that the order of partitions matters within a calling search space is when there is a direct tie for the DN contained within the partition. So here we have DN 8000 in partition RTP and DN 8000 in partition San Jose. So those DNs are direct matches. However, they are considered separate DNs. They're not shared lines. They would be a shared line if they were in the same partition. And really those could only be DNs that were assigned to phones. Hunt Pilots could not have a shared Hunt Pilot number. But they're not shared DNs or shared lines. They're separate DNs. They just happen to have the exact same number. They're equal longest matches. So the San Jose partition and the RTP partition both must be within the calling search space of whomever is sending the call into CUCM, maybe a gateway from the PSTN or maybe another IP phone. So whether it's the gateway inbound calling search space or the phone calling search space, which again is an inbound calling search space, either way, if the CSS sees these partitions, it needs to see both, simply in order to make this time of day example work. It doesn't have to, but to make this time of day routing example work, it does. And one of them would have to be ordered higher. What you'll see right now is that it doesn't matter. Now, if they have overlapping periods, then it would matter. So Hunt Pilot 2, if that just happens to be the name with the DN 8000, sends to the Hunt list, sends to the line group, sends across the WAN to the San Jose IP phones. So the San Jose partition has a San Jose time schedule which contains 3 periods. Time periods. One is the same as the RTP time period, which is, so it's probably using the exact same time period. And that is the no business on bank holiday of July 4th. So the time period Monday through Friday is 9 a.m., but this is Pacific Standard Time, which is GMT minus 8. So there is a 3-hour difference between these two. So 9 a.m. Pacific Standard Time, or GMT minus 8, is 12 p.m. or noon Eastern Standard Time, or GMT minus 5. And these are both Monday through Friday. So basically the RTP partition is, or the RTP Hunt Pilot 1 is taking calls Monday through Friday from 8 a.m. Eastern Standard Time until noon. And then at that same time, it's also concurrently 9 a.m. Pacific Standard Time. So this time period picks up, this partition becomes active, and this is why it really doesn't matter which one is placed, higher in the calling search space, because there is no overlap. Now, if there was an overlap, if maybe this San Jose partition picked up calls at 8 a.m., then it would matter which one was first. If we wanted RTP to get the calls, we would need to make sure that that partition was ordered higher. The idea with time of day routing is not to have overlaps because it will never get to the next partition, right? If there's a direct tie, then the RTP partition would always win. And even if the San Jose partition had an overlap in a time period, if it was ordered lower in the calling search space, it would never take the calls until this time period was shut off at 12 p.m. Eastern, which is 9 a.m. Pacific. So you could put this to 8 a.m., but as long as San Jose was ordered lower, it really wouldn't matter. They would still begin at 9 a.m. So you want to devise them and create your time periods as intelligently as possible, and put some thought into it. Okay, then this has 8 a.m. to 1700 hours, but on Saturday. And then this one was 8 a.m. to 1700 hours on Sunday. Now, does this mean that they are both covering all day, the same time period, but one's covering Saturday and one's covering Sunday? At quick glance, you might say yes, but it's not true. This is 8 a.m. Pacific time. So that's 9, 10, 11 a.m. Eastern time. So actually, on Saturday, phones go live for this hunt group, for this line group and hunt list and hunt pilot at 11 a.m. Eastern, 8 a.m. Pacific, and they go off at 5 p.m. Pacific or 8 p.m. Eastern. For Sunday, calls are covered at 8 a.m. Sunday, which of course is 5 a.m. Pacific time, but 8 a.m. Eastern time on Sunday until 5 p.m. or let's see, 2 p.m. Pacific on Sunday. Okay, so it's important to keep in mind the time zone and GMT offset. Okay, so call comes in 9 a.m. Eastern time on Sunday for 8,000. The call is going to be distributed to the RTP phones. If the call were to come in at 9 a.m. PST on Sunday, actually, that was a mistake. That was a copy of that little text box there. This should say if the call were to come in at 9 a.m. on Saturday, okay, as we just went over. They would be distributed to the San Jose phones. Taking a look a little bit further at hunt group call coverage, we can see that we've got a phone here, DN1001, another phone, DN2001, and then 3 phones which obviously have DNs and lines, but really aren't important. These are going to be part of our hunt group or our line group. So DN1001 goes to call 8,000. And this is an unassigned DN. So this is just a directory number that we created, and we're not assigning it anywhere. We're not assigning it to a phone, to a CTI port or a CTI route point. We could do any one of those things, but the whole reason that we're creating it is simply to have a call forward all. Now, the reasoning and desire behind wanting to do this, there's a number of different reasons why people might want to do this. I'm not going to get too much into them, but ultimately we're going to be call forwarding all to this hunt pilot. Now, this might even be an unassigned DN with the number being 8,000, but it's in a partition that everyone can see, and then the hunt pilot is in a partition that no one can see, except for this unassigned DN and its call forward all calling search space, as an example. We also might have, let's say the hunt pilot is 8,000, and this unassigned DN is, let's say, 8,001. We have another one at 8,002, another one at 8,003, and depending on which DN you call, maybe those represent different DIDs and different class of service that we have handed out to different levels of customers. Maybe silver, gold, and platinum type customer levels, or whatever. Although gold's worth a lot more than platinum at the moment. But, whatever that might be, just different tiers of service that you might choose to want to provide to a client. And that's just one example. There might be a number of reasons why we might have these. But the idea is that we have these unassigned DNs, and the entire reason for them is simply to be a forwarder. So at some points we have or will talk about using route plan report to see all numbers, all directory numbers, all patterns. Sometimes we'll take a look, and we have talked about using them to find all unassigned DNs, and there's a nice handy little button that says delete all found. Bear in mind that many times in an installation there will be intentional unassigned DNs. And so you might want to find unassigned DNs because some of them you do want to delete, such as an auto registration range that's already been used, and then you've already used the TAPS tool to, go ahead and assign the phone its proper DN, something like that. But just be careful not to always just quickly do route plan report, find all unassigned DNs, and click delete all found. There may be a purpose for some, such as what we're talking about here. So here's an unassigned DN. Whatever the DN is, we don't really care. We haven't enumerated. Maybe it's 8,000. Call forward is all. Calling search space contains the hunt pilot partition. So the hunt pilot 8,000 goes down to the hunt list, to the line group, and as you can see, it's rather quickly trying each of the 3 phones in that line group. Now, none of them were available. Maybe they rang busy. Maybe they rang no answer. Whatever the reason might be, they weren't available. The line group or overall hunt group entity extended the call to each using one of the distribution algorithms, and the line groups we can specify, and we'll take a look at in the demo, different distribution algorithms, whether they are sending to longest idle, so the person that's been idle the longest or hasn't been on the phone in the most recent amount of time. Maybe we could be sending broadcast all at once. Maybe we could be doing top down, which will always send to phone 1, then phone 2, then phone 3, but only if phone 1 is busy will it send to phone 2, and only if phone 2 and phone 1 are busy will it send to phone 3. So maybe it extends to phone 1, top-down algorithm is configured, then phone 1 is busy, another call comes, it sends to phone 2, but in the meantime, phone 1 gets cleared up, so then all of a sudden, line group sends to phone 1 again. It will always try the top to see if it's free. Or circular, where the first call gets sent to phone 1, regardless of whether that first call or first phone is busy or not, call gets sent to phone 2, next one, call gets sent to phone 3, etc. And then it goes back to the top, circles back to the top, sort of a loop. Okay, so regardless of what the distribution algorithm, all these phones were busy. And because of that, the line group also has the ability to determine, based on if it was call forward busy for each and every member of the line group, or whether it was call forward no answer, to have different choices that they can make based on those different options, whether all phones were busy or all phones were no answer, and we'll take a look at those. But right now, it's configured to simply send it back up to the hunt pilot, and on the hunt pilot, call forward no answer, let's just say, for instance, there's a separate one for call forward busy. There is a option that we can provide a destination and a calling search space, and it will take and process that. There's also a tick box for each of these on the hunt pilot only that says use personal preference. What this use personal preference does is it goes back to the unassigned DN or whomever forwarded the call. This could be that DN 1001 called 3001 and 3001 simply forwarded it to the hunt pilot. Any reason that the call was originally forwarded, either call forward all, manual transfer, whatever, but it was forwarded to the hunt pilot, if the call forward no answer for the members of the line group or call forward busy for the members of the line group was set to the tick box, use personal preference, yes, it will go back to the unassigned DN or whomever forwarded it and use the call forward no coverage. And that's why every phone, every line on every phone has this call forward no coverage, because whether it's an unassigned DN or whether it's a CTI route point that forwarded it to a hunt pilot, or whether it's a individual phone user manually forwarded it, whatever the case may be, it will come back if use personal preference is ticked and follow the call forward no coverage. And in this case, call forward no coverage is set to 2001. And of course, the call forward no coverage has a calling search space after the destination, and that would have to contain the partition that 2001 is at. But assuming it does, whoops, then the call would be sent down to DN 2001. Something else we'd like to take a look at is client matter codes. So let's say that we have a phone and it places a local call, dials a local pattern. And we have a route pattern using the @ logic, or it could just be a regular pattern. It doesn't have to necessarily be @ logic with a route filter. Here we see route filter local configured, but could just be 9 dot, 2 through 9XX, 2 through 9XX, XXXX, could be 4, 5, 7, 8, 9. Really doesn't matter what the pattern is, provided that that's what the user dialed. And there is a tick box for client matter code. And so in this case, we have CMC ticked or set to yes. So what happens is when the client, when the calling phone dials a pattern that's matched, that has this CMC ticked or set to yes, the route pattern basically instructs CUCM to send back another sort of a secondary tone, not secondary dial tone, but really a tertiary tone, if you will. But it's a special frequency and constant duration, basically saying that it's, and it doesn't physically say this, but it's effectively letting the calling party know we're waiting for a client matter code. So you need to input a code. So at this point, the calling party has the ability to dial additional DTMF digits. And in fact, they're required. So the person on the phone knows the policy. They know which client they want to associate this particular call to. That is, this is useful in financial, but certainly within legal profession, where anytime you want to bill calls to a client, then this is very useful, because what I can do is I can just go ahead and let's say I want client, I believe 2. Yeah, I can press the DTMF keypad for 643, and my CMC for 643 with the description of client 2 is matched, and therefore this is sent up to the route pattern. The CMC is matched, it's confirmed. The CDR, call detail records, have recorded this, and so when we look back at our billing server, we can tell which particular client, first of all, who was the calling party, which particular client the called number was destined to, and how long, so that we can properly bill that client. And then the call sent out to the PSTN. And we obviously could put in multiple different clients. We'd probably have hundreds, if not more. A lot of times, if someone's doing this, they'll have some generic pattern, such as I have here, like 555, or something like that for personal calls, so that they're not billed to any particular client, or office-based calls for like an office manager. But whatever the case may be, we would have a code for each client. Now, the important thing is, if we're using these patterns, we need to make sure that each and every pattern for the most likely 4 classes of service, probably restricted, which actually probably restricted wouldn't have any client matter codes. That would probably entail emergency services, so 911 or 999 or 112 or something like that, as well as internal numbers. And internal numbers do not have client matter codes available to be assigned. But at least for local calls, national or long distance calls, and international calls, we would have client matter codes. So it's important that we make sure that if we have multiple sites and if we happen to have multiple patterns, that they most likely all probably follow the same schema. Now, let's say we did have an office manager for a legal firm that wanted to be able to dial calls for the office and was never dialing clients for whatever reason, not an assistant to not a legal assistant of some sort, but actually just an office manager. And the firm tasked us, the consultant, with actually creating a way so that this particular office manager did not have to ever dial any client matter codes. Well, the only way to keep things separate so that they didn't overlap, and so that a particular phone that was intended to dial client matter codes didn't possibly reach ambiguity or ambiguous patterns one that had 9.at with route filter local that had CMC yes, and the other that had route filter 9.at, pattern 9.at with route filter local and CMC no, or not ticked, would be with separate partitions and therefore separate calling search spaces. So that would be one way. Similar to client matter codes, but very different in their operation and reasoning. So similar in the sense that, really only in the sense that once we dial the initial pattern to be matched, that they have to dial additional DTMF digits to complete their call. But are forced authorization codes. And first we're going to look at an actual authorized example, and then we'll look at an unauthorized example. So with forced authorization codes, the idea is that we don't necessarily want to have calling search spaces be responsible for our class of restriction, as we certainly have looked at and know that we can do. But instead, we want to give everyone, and this seems like a good idea, but actually you'll probably find that this isn't used that often. It certainly is in some places. In fact, the types of the vertical of clients that I have typically installed forced authorization codes for are higher level learning university type college applications. So those typically be are the types of people that want them, and really where these come into play are if you have users that don't want to sign in with extension mobility and therefore pull a different class of restriction down with their line down to the device that they're logging into, but they do still want to be able to go to any phone on, let's say a campus, for instance, a university campus, and they want to be able to dial from any phone, and they need to be able to possibly have as high as international dialing rights. But then again, as soon as they leave that phone, they're not going to log out because we're not using extension mobility. And so the next person that comes up might be a student, and we don't want them to have international dialing rights. So again, the times when these are typically the most used are when we're not using extension mobility, but when any user should be able to go to any phone and dial any pattern, provided that they have the proper level of access. Now, obviously, one of the challenges is keeping these codes, these forced authorization codes, the higher level codes, which give you more access to things like international route patterns, keeping these secret. And also, I should mention that currently, though this may change in the future, currently forced authorization codes and client matter codes can only be dialed if route patterns are directly matched. So you can't really be going through a translation pattern to get here. You need to be going directly through a route pattern. So the phone needs to be dialing a pattern that is by the calling party phone reaching the dialed digit match, or the route patterns partition needs to be dialing direct. Okay, we don't have FACs or CMC tick boxes on translation patterns yet, at least. So here we see that we've got a route pattern for 9.at. Actually, they're all 9.at, but they have route filter local, long distance, and international, respectively. FAC is set to yes on all three, and the level that's required for local is 10, the level required for long distance is 20, and the level required for international is 30. So the calling party dials a long distance pattern, and the tone is sent back saying wait for forced authorization code match. So the calling party, let's say, dials DTMF 2179. So authentication level 20 is provided to the original route pattern, and the FAC pattern match, the level has to be greater than or equal to the required pattern level. And of course, CDR is recorded. So here, the authorization level could be 20, could be 25. The important thing is that it's equal to or greater than what's on the pattern. In this case, it is, and so the call is sent out to the PSTN. Looking at an unauthorized example, same thing happens, except this time the phone, let's say the same phone, doesn't really matter actually which phone, the calling space, search space of the phone, and in fact the idea, not that it has to be this way campus-wide or cluster-wide, but the idea is that all phones have access to all of these patterns. So the calling search space on the device of the phone has access to the partition of all of these patterns. They can dial an international pattern. It doesn't mean the call will go through, but they do have the ability to dial it. So this person does dial an international pattern. The tone is sent back, wait for the forced authorization code match. Let's say they dial 2179, which has, that's the only code they know, and it has an authorization level of 20. In this case, the FAC pattern match, the level is not greater than or equal to the level on the pattern because the level dialed was 20 for the code and the level required is 30. So therefore the call does not go through and they get reorder tone. So we also want to take a look at something called automated alternate routing. And we're just going to look at the concept right now. In terms of actually putting this into play, we're going to put this into play later when we bring in a future concept called globalization, because it's going to make everything much easier. But we're going to certainly take a look at the concept and understand what automated alternate routing is. So, and in CUCM 8 and beyond, there are a few different methods of automated alternate routing. One is what we're going to look at here. This is the traditional automated alternate routing. There's also a form of automated alternate routing that goes along with something called call control discovery, or CCD, also referred to as SAF CCD, if you've ever seen it that way. We'll go into what that is in the CCNP voice studies, because you don't need to know it for this level, but that is, or call control discovery can have a form of automated alternate routing. And the idea of automated alternate routing, whether we're talking about this traditional type or the augmentation to the CCD, or call control discovery, the idea is that if we can't get to a given site through the WAN, we reroute over the PSTN. So we'll take a look here. We've got a phone, DN1001, that dials 2001. And the idea is that normally they would place this call, DN2001 being at a different site across the WAN, normally they would place this call over the WAN through the same CUCM cluster. However, if locations-based CAC, whether this is traditional, just standard CCM location-based CAC, or whether this is RSVP-enabled location-based CAC, really doesn't matter, but location-based CAC for one reason or another, so within CUCM or even reported by a router running the RSVP agent, reports that there is not enough bandwidth. Okay, this is not for WAN down, this is just not enough bandwidth. So what happens is CUCM checks to see if AAR is enabled, and if so, then network congestion rerouting, network congestion, rerouting is displayed at the bottom of the calling party phone display, and we go on trying to route the call. Now, before I go on, if AAR is not enabled, then all we see at the bottom of the display is not enough bandwidth. And those messages are configurable in the CUCM service parameters. But assuming AAR is enabled, we see network congestion rerouting, and then the external phone number mask or the AAR destination number of the called party, or DNIS, the called party, is gathered, is garnered. We obtain either that external phone number mask or a better use, and we'll go into these. The AAR destination number overrides the external phone number mask. That way, the external phone number mask always shows, if I can keep my mouse here, and whenever I mouse over there, for some reason it's going away. Anyway, at the top right-hand corner of every phone, we see a number, and that is populated by the external phone number mask. So if we want to keep the external phone number mask or the top right of the phone display to say one thing, But, and on some of the newer phones like the 9971, it's actually in the middle of the top of the display rather than at the right of the top of the display. But regardless, we want to keep that as one thing, but we want to have AAR use something else. Then a better use is the field called the AAR destination number. Regardless, the called party, external phone, or AAR destination is obtained. And then we take a combination, the matrix C, of the AAR prefix, and the AAR prefix is obtained by the AAR group of the calling party and the AAR group of the called party. So here we see that AAR corporate headquarters to the matrix, AAR branch 1 equals the AAR prefix of 91. So the digits transformed because we prefix that AAR prefix to the AAR destination number or external phone number mask of the called party, and the external phone number mask was 512-602-2XXX, which is 2001 because that XXX is a mask, and we prefix the 91. So now we have a new pattern of 91-512-602-2001. This is used and basically sent back into the digit analysis engine to match a new translation pattern or route pattern. But this new match needs to be visible by the calling party's AAR CSS. Now, maybe the calling party only has restricted rights. That is, they can dial internal DNs like 2001, or they can dial, emergency services. But they do not have the ability to dial even local calls, much less national or long-distance calls. Typically, now not always, obviously the company policy determines this, but typically the AAR CSS will have more privileges than your traditional CSS, unless of course your traditional CSS is international calling for your class of restriction. Then your AAR would probably be equal. But the idea is that the user just dialed 2001. Typically, they shouldn't be penalized just because the call had to reroute over the PSTN or, telco, just because there wasn't enough WAN bandwidth. And really, the dialing should be, in most situations, transparent to the user. Again, this is going to be determined based on how whatever lab you're working on or whatever exam you're working on interprets the type of question. Okay? So in this case, whether the calling search space, the traditional calling search space, only contained local or not even local, just internal DNs, the AAR calling search space for this calling party needs to have, if we want this call to complete, 91, so that's in the US, 9 would be the secondary dial tone, and 1 would be a national code. If we're talking about, maybe most other countries, 0 for secondary dial tone and 0 for national dialing. So 00 as the prefix. But again, that would need to be able to be matched. So the translation pattern or route pattern that contains that 91-512-602-2001 match, the partition has to be in the calling party's AAR CSS, and then the call reroutes over the PSTN gateway. Now, there is one other form of rerouting, and some people refer to it as AAR or a form of automated alternate routing. Some people simply refer to it as, an alternate form of routing, but they don't necessarily call it automated alternate routing. It just depends in terms of the pedantic specifics of, what it's necessarily referred to as. But this is known as CFR, or call forward unregister. Now, we talked about this form of automated alternate routing, the most traditional, in fact, the oldest form that's been in CUCM the longest, is based only, not if there's a WAN down situation at all, or if the phone on the other end, the called party, not if that phone is unregistered, whether they, accidentally unplugged their phone or unplugged it to move or whatever. Okay, but but only in the case of the called party phone being registered to CUCM and bandwidth being used in the form of call admission control, location or RSVP-based locations, CAC. First of all, that only stops RTP media from going across the WAN, right? It does not stop signaling. So SIP signaling to a phone, skinny signaling to a phone, SIP and skinny, H323 and MGCP signaling to a remote gateway. That will always go across the WAN, even if call admission control says there's not enough bandwidth for the RTP media stream to go across the WAN. Okay, signaling's never inhibited by call admission control. But what is inhibited is the, as we said, RTP media. So to the called phone or even to a called gateway. Maybe I make a call that, according to the programming, should route over the WAN out this particular gateway, a far end gateway, to the PSTN. And that's why both phones and gateways / trunks all have locations. Okay, so my location, corporate headquarters, and this location or the phone over here location might be branch 1. So if there's not enough WAN bandwidth to complete another call, I can't make a call to the far phone, but I also can't make a call out a far PSTN gateway. I would have to have a fallback gateway for my pattern. Okay, but if we're not talking about not enough bandwidth, what we are talking about is, let's say we had a WAN down. So the WAN link goes down at branch 1, just completely goes off hook, not off hook, I shouldn't use that word, but goes off availability, maybe a line gets cut, a fiber line, that. And so this router, maybe it's configured for SRST, survivable remote site telephony, and the phones all over at that branch 1 site all registered to this local SRST router, and all of their calls are sent through the PSTN. Okay, first of all, if they want to dial 4-digit numbers, that has to be done, and we'll take a look at this in the high availability section a lot more. But those calls have to be done through the router by use of either dial peers or a combination of dial peers and voice translation patterns, matching 4-digit numbers and then doing some form of digit manipulation to send them on to the PSTN and then back to the primary site. Okay, that's for the remote site and their dialing of 4-digit extensions, or their continuity of being able to continue to dial 4-digit extensions. At the corporate headquarters site, that is the phones that are still registered to CUCM. CUCM sees that those, that 2001 and all the branch 1 phones are no longer registered. It puts them in an unregistered state. So when DN 1001 goes to call 2001, the call forward unregister, also referred to CFR, CFUR, CFR is how people pronounce it, that takes effect, and that, depending on how you've configured that, will allow calls to reroute over the PSTN as well. Okay, so that can be viewed as another form of automated alternate routing.